Hi class. So today we are going to be doing this one, right? Binomial versus geometric random variables. So this exercise it's not difficult, but before we start, you have to understand the difference between binomial versus geometric random variable. So let's do a quick recap. So here, what we are doing is this. So binomial, right? Uh-oh, binomial random variable versus geometric, right? Geometric random variable. Okay. So first thing first, I need you to recall, right, that for binomial, remember the BINS, bins? So binary outcomes, right? Binary outcomes. Um, that means two outcomes, either success or failure. um, when you throw a die, they want to see if you can get a one on the die, so it's either a one or not a one. So there are always two different outcomes, right? Success or failure. For geometric, it's the same thing. It has B also, and it's the same idea, binary outcomes, right? Both have the same. I stands for independence, right? Independence are the trials independent from each other. And if they don't state that, you typically or sometimes have to check the 10% rule. And what does the 10% rule says? It says that the sample size should be less than 10% of the population size. Okay? Sample size is less than sample size is less than or equals to typically just less than, okay, less than 10% 0.1 of the big N, the sample size. Okay? And then N is the number of trials, right? Number of trials. Number of trials. Oh, by the way, the independence rule is the same thing for geometric. Okay? The trials are independent, or you need to check the 10% rule. Right? Checking the 10% rule means the sample size is less than 0.1, or also known as 10% of the population size. Now, the only difference between binomial and geometric is this, right? This is the only difference. So the number of trials is fixed, right? Number of trials is fixed for binomial. And here is T. The trials are unknown, right? The trials are unknown. So they don't really tell you the number of trials or what n is. There's no n, right? No n. Now, what does that mean? That means, so let's say if you roll a die, you roll until you get a two, right? So in doing so, you don't know how many rolls you're going to do, right? You don't know. Or like standing at the door and collecting information from a student until the student tell you that he drives a Tesla. So you don't really know how many students you're going to be sampling or asking until the answer comes up that the person drives a Tesla. So the n, there's no n, right, for geometric. S here for binomial stands for same probability of success, right? Same probability, right, of success. So it's the same idea. So same thing from here goes to here. Same probability of success. So you really, really need to read the question to see if it satisfies B, right? Satisfy B, I, T, S bits, or satisfy B, I, N, S bits. Okay, so if you go, let's dive in. Leo selects 25. There's no math involved in here. So you just need to kind of read the question and see if all the conditions are satisfied. Leo selects 25 grandparents at random from his town to interview. In the town, 35% of the grandparents have their grandchildren living with them. Let G be the number of grandparents Leo interviews whose grandchildren are living with them. Okay, so here there are binomial, so not binomial, there are binary outcomes, right? Whether the the grandparents that Leo interview, whether the kids, the grandchildren live with them or don't live with them. So the B is satisfied, right? Binary outcomes. I, so I'm a bit curious. In this question, it never once mentioned that the grandparents are independent from each other. So we don't really know, right, if the independence rule is satisfied. And they do not tell us how big this town is. There's only 25 grandparents selected at random from his town to interview. So from here, it looks as if, it's not a geometric, right? Because let G be the number of grandparents Leo interviews whose grandchildren are living with them. So, you know, out of 25, how many of those 25 have grandchildren living with them? So it sounds like it's a binomial, but I won't say it's a binomial now because the independence rule is not stated. So I would say in this case, neither. Oops. Well, so the trials are independent. The trials are independent, and the probability of success remain the same. So they are claiming that the trials are independent, okay, and that the what was it? That the probability of success remain the same, and the probability of success is 0.35. So if that's the case, it's binomial. Okay, that's I don't I'm not sure why that is so. I would have picked because I don't see that the independence rule. Um, So let's try this. In a game involving a standard deck of 52 playing cards, an individual randomly draws 6 cards without replacement. And let Y be the number of aces drawn. So this is clearly a binomial. It's not a geometric, but did this binomial random variable fulfill all the conditions? So B, all right, aces or not aces, all right? I, is it independent? It doesn't look like it's independent because you're drawing 6 cards without replacement. So, right, neither. So here, Alma wrote a phone app. She has noticed that 3% of the users who download her app upgrade it the same day. Let M be the number of customers who download Emma app, Alma app until one upgrades it on the same day. So see how until one upgrades it on the same day. So it's still B, upgrades or don't upgrade. All right. And I is independent. Okay. All right. See, assume that the probability of each user's upgrades are independent. Woohoo. And then the probability of success is 3%. Woohoo. And so here the number of trials, N, not the number of trials. We don't know what N is. N is not given in this case. So looks like, sounds like it's geometric. All right. Okay. So do one more and then we stop. Haley selects 10 small businesses at random from a state's directory. Let B be the number of businesses she selects that have websites. So sounds like it's independent. Um, no, the state directory, so small businesses, so 10. So I think the 10% rule would be satisfied, right? We are assuming that there are more than 100 small businesses in the state. So let B be the number of businesses she selects that have website. So it's either have website or don't have website. So it's B, right? Right, it's binomial, so it satisfies all the conditions. So please, if you have any questions, let me know, and I'll go and do the next exercise. Thank you.